Welcome back to the channel. Today's video we have one final type of factoring question with polynomials that we have not discussed yet in this chapter. You know, we've done a lot of stuff with factoring so far here at the end of the chapter. We started out factoring just simple statements where there was a greatest common factor, something like, I don't know, I'm just going to make one up, something like this, where you could divide everything by 3. Then we kind of worked our way up where we were factoring trinomials with kind of using mental math, right? What two numbers multiply together to equal 12 that add up to equal 7. Once we kind of got the hang of those, we graduated up to multiplying factoring the polynomials that don't have a coefficient of 1. Maybe something that looked like this, and I'm just making this up. This may not be factorable, so don't actually try to work it out and then get mad if it doesn't work. We'd do a question like that maybe, and then we started looking at some of the special cases, right? Some of the special cases where we had a difference of 2 squares, right? 2 perfect squares, and then even in yesterday's video, we started to do questions that were a perfect square trinomial where both of the terms, like here and here, were perfect squares, and the one in the middle wasn't a perfect square, whatever that was. It doesn't really matter. But whatever that is not a perfect square. So we've done all these different type of factoring. We've even done them when they were equations and they equaled 0. We've done the zero product property. We've done a whole bunch of stuff with factoring. But if you look at all of these statements are either trinomials or up here binomials. What happens when they give you more than a trinomial? Oh boy, all right? You've probably already looked here at number 1 and number 2 on my board. These have 4 terms. Whoa, right? Automatically, I'm overwhelmed. Automatically, I want to raise my hand. I don't know what I'm doing. I want to give up. I want to say this is stupid. I want to look it up on my phone, right? Automatically, I'm starting to get panicked because this has 4 terms in it. 1, 2, 3, 4. 4 parts that are being added or subtracted. On this board, it's all adding just to start out with an easier one. But how do we do this when there's more than 3 terms? It's not a trinomial. Now we have 4 terms. Okay, we're going to use a strategy called grouping. It's pretty nice. What you want to do is you want to look for terms that have something in common. If you can group it into 2 and 2, right? Find 2 terms that have something in common, a greatest common factor, and then find 2 other terms that have a greatest common factor, and then group those together. For example, what I always try to do first is I just want to look at the first 2, right? And so if I just kind of put a bracket around that instead of a parentheses, do those 2 have anything in common? Yeah, they do, right? They both have a letter X. And so then if I put those 2 in a group, and then I put these 2 in a group, and you can make them parentheses or brackets, it really doesn't matter. In my orange parentheses, do those 2 terms have something in common? Is there a greatest common factor there? Could they both be divided by the same number? Yeah, those can both be divided by 3, right? And so that's what you're looking for. You want to try to group them together so that the 2 terms in your parentheses have a greatest common factor. They have something in common that you can divide them both by. Factor it out. So, for example, on my very first one here, in my blue bracket, I'm going to look at that and say, hey, okay, what do those have in common? Well, the numbers don't go into each other. 3 and 5 don't really have much going on there. But the x's, right? Both of these terms have x's in it. Do they both have 1 x? Yeah, they both have at least 1 letter x. Do both of these have at least 2 x's? Yes, this one has 3, this one has 2. Do both of these have at least 3 x's? No. So I could say that both of these terms have at least 2 x's, right? X squared. And so if I take that away, I'm going to factor out x squared. That means I'm going to take away 2 x's from each of these terms. So if I took away 2 of the x's, what would be left? If I took away 2 of the x's here, instead of being x to the third, it's just going to be x to the first, which you can put a 1 on there if you want, but it really doesn't matter. Here, if you took away the 2 x's, you don't have any x's left. All you have is the 5, right? So we factored the first group that we made. Okay. Now let's go to the second parentheses. In my second parentheses, I'm just going to drop down this plus sign because it's right there. What do these 2 terms have in common? Right here, these can both the numbers can go into 3, right? So I'm going to divide both these by 3. That's the only thing they have in common. And now let's see what's left over. If I do 9x divided by 3, 9 divided by 3 is 3. If I do 15 divided by 3, 15 divided by 3 is 5. And look what we have. You'll know you're doing these right if your parentheses are identical, right? This is a giant clue that you have done it correctly. If you do this step and your parentheses are not the exact same, you need to stop and look back, because either A, you've messed up whenever you factored something out, or B, you grouped them wrong, and maybe there was a different way to group them that would have worked better. Okay, we've actually done all the work here. That's all the work that we need to do. We're ready for our final answer. Okay, so if you look at what we have, how do I write this as a final answer? What does this and this, what do those two have in common? They both have the 3x plus 5, right? The parentheses, that was the exact same. That's part of your answer. And then what's the other part of your answer? The other part of your answer is, what did I factor out of each group in my original statement, right? I factored out x squared out of the first one. I factored out positive 3 from the second one. And that's it, right? That is your answer. So one more time, the parentheses that you had in common, right? 3x plus 5, 3x plus 5, that's the first part of your answer. Or actually, it doesn't matter. You can have them flipped. That's one part of your answer. And then the two GCFs, the two things that you factored out, those go into parentheses, and that's the second part of your answer, which it could actually be at the front. It really doesn't matter. You could have these parentheses reversed, and it'll be okay. All right, so that's really not too bad once you get the hang of it. But let's try another one. Let's look at number 2. I just kind of default. I try to always just group the first two together if I can, and then I'll group the second two together if I can, if it's possible. So in my blue parentheses, would these two have something in common? Yeah, let's see. They could both be divided by 2. Oh, and they both have at least a letter y, right? They both have a letter y, and they can both be divided by 2. So if I divide them by 2 and I take away a y, what was going to be left? 2 divided by 2 is 1. And then if I take away the y from y squared, and it's just going to be y to the first. Here, 8 divided by 2 is 4. If I take away the y, all I have left is the x. Okay, I factored the first group, and I'm going to factor the second group. Both of these, oh boy, they can be divided by 10. Do they have any variables in common? Y to the third and y to the second. So they both have at least 2 letter y's. I can take 2 letter y's away from each one. If I do that, 10 divided by 10 is 1. And then if I take away 2 y's, I started with 3. That means there's only 1 y left. Over here, 40 divided by 10 is 4. If I take away the 2 y's, I don't have any y's left, but I just still have the letter x. Okay, do a quick discount double check. Is something looking similar here, right? Are my parentheses matching? You bet they are, right? So that is the first part of my answer, and it could be at the end, but I like to put it at the front. I don't really want to put that 1 on there. I'm just going to put y plus 4x. That's the first part of my answer, the parentheses, that was a perfect match. And then the second part of my answer is right here, these two greatest common factors that you factored out. These two are the GCFs. That's going to go in the other parentheses. So 2y and then plus 10y squared. Oh, whoa. Hang on. That's not actually done. I'm out of space. Let me write it up here. Do you see maybe why I'm feeling like that's not the perfect answer? Look at my black parentheses that I just wrote. I know you can't really see it. Let me scoot it over. Let me erase this one because I really have 2 of them there and there's really just 1. If you look at my black parentheses, I've kind of got a problem. It's not the biggest problem in the world, but don't these 2 terms, don't they have something in common, right? Can I still factor something out of here? And actually, I can, right? Can't I divide both these by 2? And don't they both have a y in them? So if I was being really good on this, I should say, wait a second, this is not factored all the way yet, right? This is not completely factored. I can divide both those by 2, and I can take a y away from both of them. So let me actually do that way down here. If I divide them by 2, and I take away a y, instead of 2y, if I divide it by 2 and I take away a y, there's nothing left except for the number 1. Over here, if I divide by 2, That gives me 5. And if I take away one of the y's, instead of being y squared, it's just going to be y to the first. So this, if I distribute it, is the same thing as that. But now there's nothing in common here. So I actually did have to check that one a little bit. The second parentheses is still good. This one did not have anything in common. And so this actually looks like that. Sometimes that'll happen every once in a while. I didn't really intend for that to happen. I just made these questions up on my own. But sometimes you need to double check in your final answer. Is there a greatest common factor here? Is there a greatest common factor here? Because if there is, you'll have to factor that out as well. Okay, let me go to another board. I think I've got 2 more. I haven't shown you any with subtracting signs yet, so we're going to put a couple subtracting signs in this one. All right, let's do this next one. Sometimes you'll do something, you just get in a habit, like you just get in a habit of saying, okay, I'm going to group these 2 together, and then I'm going to group these 2 together. And then all of a sudden you get ready to do it, and you're like, okay, what do the first 2 terms have in common? Oh, right? Is there anything in common here? Can I divide those by 2 or 3 or no? Do they have the same variable? No. This grouping is not going to work, right? Now, these had something in common. I could divide those by 3, and they both have a w in them. But these 2 don't have anything in common. So it's not always going to be the first 2 and then the second 2, right? Sometimes you'll have to kind of rearrange the terms, right? You'll need to group them a little bit differently to make it work. It's kind of awkward having to erase it like that without trying to erase the whole question. So instead of grouping it the way that I have been on this question, I might have to do maybe I think this one can go with this one because they both have a w in them, right? So maybe what I want to do on this one is rewrite it and put the 2 w's together, right? I'm going to put these 2 that have w's right here in blue in the same parentheses. And then I'm going to put this one and this one that both have a y in them. I'm going to put these 2 in my second parentheses. 18yw. So don't be scared to rewrite the whole question and kind of rearrange it if you need to. Okay. So if we are going to do this one this way, in my blue parentheses right here, they both have a w. I can take away a w. I can also divide them both by 5. So if I divide both numbers by 5 and I take away a w, what's left over? 5w divided by 5w is just 1. And then in this one, 15 divided by 5 is 3. If I take away a w, instead of having 2, I only have 1 left. That says 3w. Sorry about that. In my purple parentheses, these, they both could be divided by 6. And they both have a letter y, so I can take away a letter y and divide them by 6. If I divide them by 6 and take away a y, 6y divided by 6y is 1. And then 18 divided by 6 is 3. If I take away the y, I just have the w left. And now look at this. This looks pretty good, right? My parentheses here and here are the exact same. So that's going to be the first part of my answer, 1 plus 3w. And then the second part of my answer is going to be these 2 greatest common factors, 5w plus 6y, the 2 things that we factored out of each group once we got it grouped the right way. Okay? Now, if you were really curious, you're doing this on a test, you're really wanting to make sure you've got it right, you're doing this for $1 million, could I do distributive property or FOIL and work this out and see if I come back with the original statement? Yes, you can. I may do that on the very last one just to show you. Okay, another one. Here we have a couple subtracting signs. I think we might be able to group it, though, with the first 2 in one group and the second 2 in another group. Let me just double check. Let's give it a try and see. If we do it this way, with the first 2 and then the second 2, do I have something in common here? Yeah, they both have at least a letter A, and they can both go into 5. So if I can do 5 and A, what would be left over? 20 divided by 5 is 4. If I took away an A, instead of being a to the third, it's going to be a to the second. Here, 15 divided by 5 is 3. Now, this has a subtracting sign, but that's all right. If I took away the A, I don't have any A's left, so I'm just going to leave that empty. The second parentheses, let me see, 12, those can both go into 3. 12 and 9 both go into 3. And then what would be left over? Let's see, 12 divided by 3 is 4a squared. And then the minus sign is still there. 9 divided by 3 is 3. And now do a double check. Is it going to work? Are my parentheses the same? Yes, yes. My two parentheses here are perfect matches. So that's going to be the first parentheses, the first part of my answer. There's no greatest common factor there. There's nothing in common. And then the two GCFs, right? Here was our greatest common factor. And then, whoops, right here was our other greatest common factor. These are going to be 5a and plus 3 are going to go into my second parentheses. Okay? All right, we're doing all right. We have one more board. Grand finale. All right, for number 5, our grand finale. Sometimes the subtracting signs or the minus signs really mess me up, but we're going to do the best we can on this one. Let's try to do these two together. And then, you see how we have that subtracting sign right there? And that really throws some people off. You know what? What I like to do is I like to just switch it to a plus and then put, leave, change, opposite. I just like to do that just to make sure it looks okay. Some people don't do that. Some people can do the question by just saying, okay, there's my group right there, and they can make it work. I don't know. That kind of confuses people. You know what? Maybe I should just erase that. Let me show you how to do it the other way, and then I'll let you decide how you want to do it. Okay, let's try to just do this one like normal and act like it's not going to bother us. Okay, in my first parentheses, my red one, both those numbers can go into 4. I see an A in both of them. So if I divide them by 4 and take away at least one letter A, I'm going to be left with 1 and then A to the first. And then here it's going to be 16 divided by 4 is 4, and then I still have a B left. Okay, if you're looking at this other parentheses, and it's kind of distracting because you have a minus sign there, all you really need to do is think about, okay, I need to divide these by 6, but because it starts with a negative, I need to divide it by negative 6, right? Because you can't have that first term be a negative. And so what some people do is they just say, all right, let's divide them by negative 6. And so that would leave you with the letter A, and then negative 24 divided by negative 6 would be positive 4B. And you see how now, that's an A, it doesn't look very good. Now your parentheses are the exact same, 1A plus 4B, 1A plus 4B. And so A plus 4B is in one of your parentheses. The other parentheses is, oh boy, I see something that's going to happen on this one, right? 4A minus 6. Now hold up. 4A minus 6, there's something wrong with that, right? These 4A minus 6, these two terms still have something in common. I could still divide 2 out of both of those. So if I want to be really good and make sure my answer is perfect, I'm going to say, hey, whoa, hold up. These can still be factored again. You can take a 2 away from both of those. So if I divide them by 2, what would be left over? 2A and minus 3. Do you see how the parentheses from the back came to the front? It's really not a big deal. This parentheses, it was at the front. I'm just going to put it at the end. As long as you have the right stuff, it doesn't really matter the order that it goes in. That'll work on that one. Okay, grand finale, last one. We've got minus signs all over this thing. If you don't like what I did up there and you thought that was really confusing and that just hurt your brain, one thing you can do at the very beginning, if you hate subtracting signs in these, because I sometimes think they're kind of confusing, you can automatically, right at the very beginning, just rewrite the question and say, okay, instead of a minus sign, I'm going to do plus, and then do the opposite right here, plus negative 15xy, right? And then here's another subtracting sign. If that's going to confuse you, just switch it to a plus, and then do the opposite and make this negative 4xy squared. This one I'm not going to change because it already is adding, right? The only things I switch are the subtracting signs to adding signs. So if you really feel like you need to do that because it's going to hurt your brain, you can go ahead and do it that way. All right, I'm going to try to group this one with these two in the first parentheses, and then these two in the second. And we'll see if it works. If it works, great. If it doesn't work, we'll figure out what we need to do. In this first bracket, what do these have in common? I can divide them both by 5, and they both have at least a letter Y. So I'm going to do 5. I'm going to do Y. And then what's left over if I divide both of these by 5 and I take away one letter Y? 5 divided by 5 is 1. If I take away 1y, instead of being y to the third, it's going to be y to the second. Here, instead of doing plus negative, you can just put minus. That's the same thing. 15 divided by 5 is 3. If I took away the y, I don't have a y anymore. I just have an x. All right, we're looking good so far. Now, in my red parentheses or red bracket here, I've got a plus sign right there. I can drop that down, but I see a problem. This starts with a negative, so I want to divide this by negative 4 instead of positive 4. Oh, and they also have an x in them. So I'm going to take away negative 4, and they also have an x. So you see these subtracting signs just kind of make it a little bit messy. Like this really bothers some people. They're like, wait a second, can you just erase that plus sign and put minus 4x? Yeah, you can. If you want to put the plus sign in there, it's okay. It's not really a big deal. But anyway, let's go back to the question. If you divide it by negative 4 and you take away an x, you just have 1y squared. And instead of positive 12x squared, if I'm dividing this by negative 4, 12 divided by negative 4 is negative 3. And x squared, if I took away one of the x's, is now just going to be regular x. And if you look, now we're looking pretty good because our parentheses are the same, right? This and this are the exact same. And we get, I'm not going to put the 1, but we do get y squared minus 3x. In the other parentheses, we should have the two leftovers, the two GCFs right here. You really don't have to put plus negative 4x. You can if you wanted. If you wanted to put plus negative 4x right here, it would be okay, but most people just put minus 4x. They really won't have to put that plus negative. That's really not necessary. Okay. You know what, guys? I think that's it. I did want to show you one last thing. Sometimes you can group the questions a different way and you'll still get the right answer. For example, I think on number 6, you know how right here I grouped the first two together and then I grouped the last two together? It would have worked if you grouped it the other way, right? For example, if I erase this, instead of grouping the first two and then the second two, if I put like the first one with this one, it would still work. I believe it'll still work, right? Sometimes it doesn't always have to be the first two and the second two. Like for example, here's the first term and the third term, and then maybe I take this one, I'm going to put a box around it with this one. I think you'll still be able to get the right answer, even if you don't always just do the first two and the second two. Now, in my experience, doing the first two in one group and the second two in another group, if it's possible, is the best way to do it. But it still would work, I think. Let me double check. On this one, what do they have in common? They both have y's. They both have two y's. And then what would be left over? 5y minus 4x. On this one, it's a little more complicated because you have this minus sign. So I'm not just going to divide them by 3. I'm going to divide it by negative 3 because both these numbers could go into negative 3. Oh, and they both have an x. So I'm going to divide it by negative 3, and I'm going to take away an x, and I'm going to see what's left over. Negative 15 divided by negative 3 is 5. And then 12, positive 12, divided by negative 3 is negative 4. And now look what we have. We have the same answer, but look, when we did it earlier, I erased it, the parentheses that was the same was this one. Now look what's the same. This parentheses is the same. And so we have the same answer. See how this and this, it's the same thing? But now the GCFs were over here. These were the GCFs, y squared minus 3x. And so you get the same answer right here as we have right above it. These two are the exact same. The only difference is that they're in an opposite order. So it's just kind of going to work off of your preference, how you like to group them. But I believe that's it, guys. If you're a student in my Big Ideas math class, I'll go ahead and assign a few of these questions. There's really not too many in the book, so it might only be 6 or 7 questions today. Give it your best shot. If you're struggling, you want to rewind the video, pause it, go back, you want to email me, ask me a question, that's fine. But that is going to be our assignment for today, and I hope you guys have a good day and stay safe.